All right, this is the review for chapter 5. And for the first part here, we're just doing a basic, what's the derivative integral rules for these things. So the derivative of e to the x is just e to the x. It's its own derivative. Therefore, it's its own integral too when you come backwards. The integral of 1 over x is natural log of x plus c. 2 natural log of 4. If we brought that 2 up, the little rule there tells us we can bring that up as an exponent. So 4 squared would put us at 16. Okay. We take the derivative of this. Again, we would repeat e to the 6x squared times the derivative of the exponent, which is 12x. It's like a chain rule. This is inside of e to the x. So you do the derivative of e, which is itself, and then times the derivative of the inner function. E, they put the dx up here. It's no different than b. It's just where the dx is located. So this is still natural log of x plus c. And technically, I should be putting the absolute value on there. And then the derivative of natural log sine x. This is a chain rule as well. Sine is inside of natural log. So we take the derivative of the outside first. Derivative of natural log is 1 over, leave the inside function alone, times the derivative of the inside function, which is cosine. Now, you could put the cosine up here, and cosine over sine is the same as cotangent, so either one of those answers would be acceptable. For g, we're given a function f that contains the point 2, 8, and then we're told that g is its inverse. So right away when we do this, let's create the two different function worlds here. We have a point 2, 8 that's in the f function world. In the g, it's flipped around. Now at this point 2, 8, the derivative, the slope, is negative 3. So for g, it would be the reciprocal. It would be negative 1/3. So what does that tell us? That g prime of 8, the x value for the g point, is equal to negative 1/3. So again, if you keep it organized like this, these inverse functions are actually pretty simple. Okay. Integrating here, we need a u sub. We're going to take the whole bottom as the u, so u will be 49 plus 4x squared. That means du will be 8x dx, so dx will be du over 8x. So if we come back to here, this is the integral of x over, now we put this whole thing as u times dx, which is du over 8x. X's cancel. Bring that 8 out front. This is going to be 1/8 times the integral of 1 over u du. And that's going to integrate to natural log of the absolute value of u plus c. Now let's replace. So this is the natural log of 49 plus 4x squared. Now that's always going to be positive. X squared is always positive. Everything else in here is going to be positive. If you want to just be careful and put it in in absolute value anyway, that's okay, but you wouldn't technically need it for something like that. Okay. B, same thing. We're going to do a u sub here. The u is going to be the exponent on the e. That's what's inside of that function. So u is going to be negative x to the 4th. That means du will be negative 4x cubed dx. dx, therefore, will be du over negative 4x cubed. Come back over. We got 4x cubed times e to the u times du over negative 4x cubed. So this 4x cubed cancels. We got a negative that'll come out front. And then the integral of e to the u du is just itself. So it'll just be e to the u plus c. And then let's replace. So it'll have negative e to the negative x to the 4th plus c. That'll be our answer there. For this one, we've got another inverse function one that we're doing. And so let's go ahead and put f down. Let's put g down. We're told that g prime, we want to find g prime negative 4. So we want negative 4 to be the x value for the g, which means it'll be the y value for f. So the question then becomes, well, what would have to be the x value to make f equal to negative 4? Now, based on this function here, let's try some things that would make sense. 0 obviously isn't going to work. That gives us negative 1. We couldn't put positive values in. That's only going to create bigger positive values. So let's try negative 1. which would give me a -1 minus 2 minus 1. That would give me -4. So -1 is the x value here. Okay. Now, I want to know what the derivative of f at -1 is. So we're going to take the derivative of f here, which is 5x to the 4th plus 2. And then let's put -1 into that derivative, which will give us 5 plus 2, which is 7. So that's the slope at this point on the f function. For the g function, then, that would be the reciprocal. So g prime -4 is 1/7. Again, if we keep it organized, then it's not too bad. All right. So again, we've got an inverse function here. We've got g and f are inverses. We want to know what g prime of 1 is. So if we go f function, g function, they want to know g prime 1. So 1 is the x value for g. So the question is, when is 1 the y value for f? When is it the function value? So for f, 1 is the y value when x is 7. Okay? And when x is 7 for f, its derivative is 3. So the slope at this point of the tangent line at this point is 3, which means for g, that slope would be the reciprocal 1/3. This one says find the equation of the tangent line for g where x is 5. So now we're same idea, but this time the x value is 5 for g, which means that's the function value for f. So when did f have a function value of 5? That was when x equaled 3 for it. So the 0.35 is on the f function. That means the 0.53 is on the g function. That's the point we're going to be looking at. At the 0.35 for f, the slope, the derivative is 7. That means for g at this 0.53, the slope is 1/7. Now we have a point, we have a slope, so y minus y equals slope times x minus x. And there's our tangent equation. All right, and the last one here says find the equation of the tangent line at the point 2, 1. So they gave us the point. We have to find the derivative at 2, 1 using implicit differentiation. So first derivative of x squared would be 2x minus 3 times the derivative of natural log of y. That's going to be derivative of natural log, which is 1 over y, times the derivative of y, which is dy dx. Plus derivative of y squared, that's going to be 2y times dy dx equals derivative of 5, which is 0. Now at this point, what I would do is I'd go ahead and put 2 in for x and 1 in for y and see what happens. So if we put 2 in for x, we're going to get 4 minus 3 times 1 over 1, so 3 dy dx, plus 2 times 1 times this, so that's 2 dy dx equals 0. So if I combine there, I get 4 minus 1 dy dx equals 0, and if I add that over, the slope at that point would be 4. Okay? So we got a 0.21, slope of 4, so y minus y equals slope times x minus x. There's our equation of our tangent line.